Hey everyone, it's Miss Lloyd, and we are looking at some additional topics in trigonometry. We are looking specifically at law of sines. So when we're talking about law of sines, we are using these for an angle, side, angle, an angle, angle, side, and I made sure to write this a certain order. Side, side, angle, not angle, side, side. That's a bad word. Side, side, angle. And we always have to be aware of the letters that could spell out a bad word, if you will. So because we have side, side, angle, that our angle isn't in between or it's not set by a certain side or multiple sides, this means that we could have two triangles. We could just have one triangle, or we could have no triangle at all. So the side, side, and angle given doesn't line up appropriately. Those two sides are too small to also have that other angle. And so this has to do with the fact that sine has multiple solutions when it's positive. It could be in the first quadrant or the second quadrant. Both the first and second quadrant are within 180 degrees, which is the number of degrees you have in a triangle. So because of that, we could have multiple solutions, and it's just something we have to check for. This is something that I'm going to explore a bit more with my students in class with a few examples. Formulas for law of sines, typically you will see all three of the A, B, C stuff all written together. That tends to be a little bit confusing, so I wrote it as three separate formulas. So depending on what you're given and what you're solving for, we always have the sine of the angle within the same fraction as the side that is opposite it. So an example that we're going to look at for the triangle shown, so over on the right, angle A is going to be 31.6 degrees, angle C is 42.9, and side A is 10.4. Obviously, this isn't to scale, and that's totally fine. And they want us to figure out what side C is, so side C is going to be the side that is opposite angle C. This is what we're trying to figure out. So because we have angle A and side A, we're trying to find angle C and side C. We're looking at a bunch of angles and their opposite sides. We're going to be using sine. We're going to be using specifically the sine A and sine C. So I'm going to plug in what I know and then just start simplifying. So I'm trying to solve for C. I have a fraction equal to a fraction, so I'm going to be using the cross multiplication method. I want to get C alone, so I'm going to divide by the sine of 31.6 degrees over to the other side. And in my calculator, I can plug all of this in. I do want to make sure that I'm in degree mode since we are using sine of some degree. And once I plug that in, I'm going to end up with about 13.51 meters. We want to make sure we're in meters because they said that we were meters to begin with. I always assume tacos when my students don't label their units. And it's never tacos, unfortunately. That is my life. This next bit, I'm going to wait for my students. Look at my tiny mouse, isn't it cute? I just thought everyone should see that before I move on. And so this next one that I'm going to do is we have an angle and two sides, and they want us to find the length of side B. So I'm going to go through and kind of color and label everything because I'm a visual learner and it just makes more sense to me. All right, so if I'm going to use the law of sines, that means that I have to have the full version of two things that are opposite each other. So I have my sine of A and my side A. And then they also gave me side C, which means I could find angle C, but they want me to find side B. In order to find side B using sines, I have to have angle B. But I can't find angle B unless I have side B, or unless I have two of the angles that are in the triangle. If I have two of them, I can subtract that from 180 because we know that one triangle contains 180 degrees. So that means that before I can find my side B and before I can find angle angle B, I have to find angle C. So they kind of gave me a little hint when they gave me side C that tells me that I have what I need to find angle C. Once I have angle C, I can figure out angle B using the fact that a triangle is 180, and then I can use the law of sines to find side B. Now that I have everything plugged in so that I can find my angle C, I'm going to do my cross multiplication. I'm trying to find an angle this time, so I'm going to be moving my 25 over. And in order to get rid of the sign, I'm going to be taking the inverse of sine, so sine to the negative first. And this is what I'm going to be plugging into my calculator. It's all the stuff over here on the left. So again, when I plug this in, I want to make sure that I'm in degree mode. If I'm in radians, it's all just going to explode and be disgusting. So my angle C, when we plug this in, is about 36.97 degrees. And I always want to check this against 180. So if 36.97 is the reference, then in the second quadrant, and so I've done 180 minus the 36.97. So in the second quadrant, I would be 143.03 degrees. If my first angle was 110 degrees and I know that this is a solid angle, it's not something that I can just get rid of, then there's no way that I can have both a 110 degree angle and a 143 degree angle in the same triangle. It's over 180 degrees, it's just not going to work out. So then the only angle that I have to work with in this case is the 36.97. So now that I have my angle C, I can figure out angle B using that knowledge that one triangle is 180 degrees. And so I end up with about 33 degrees. I'm going to be using some decimals, but that's okay. You can always do a little bit more rounding if it makes you feel better. Now that I have my angle B, I can figure out side B. I always like to just reuse fractions from when I had all the information I needed, so the 110 over the 25. And now I'm going to use the angle that we found for B in order to find side B. And from here, I'm just going to do all of the cross multiplication and getting B by itself. And when I plug in all the stuff to the right on my calculator, I end up with about 14.5 centimeters. The next thing we're going to look at is when we're looking at the area of an oblique triangle. So if we have two sides and an angle that is in between, we are able to use this formula. We may have to solve for a few things in order to have all that is necessary. So I'm just going to do one example in the video. The rest I'm going to save for my students. It is pretty simple. So for this first example, we're going to find the area of a triangle that has two sides with a length of 30 feet and 48 feet, and an included angle of 40 degrees. So what they mean by included angle, they mean the angle that's in between the sides. So I'm going to draw this out mostly because it makes more sense to my brain when I do. And of course, you don't have to have this to scale. Mine is definitely not to scale. It's just kind of that seeing the angle side angle bit that is the most necessary. So we can see that the angle is in between the two sides. And because that angle is in between the two sides, and I've gone ahead and labeled A, B, and C. It doesn't necessarily have to be labeled A, B, and C, but because I've labeled it this way, I'm going to use this particular equation. And all the formulas are the same, it's just depending on what's given. So because of what I labeled, this is what I'm going to be plugging in. And when I plug all of this into my calculator, I end up with 462.01 feet squared. Don't forget that we would have done 48 feet times 30 feet, which is what gives us that feet squared. And this is all that I have for you guys today. If you have any questions, you can always put them in the comment section. If you found this helpful, please like and subscribe. And if you think this could be helpful for someone else, feel free to share it. Spread the love.